The parabola. We stated earlier that the graph of a quadratic function is a parabola. In this video, we give a geometric definition of a parabola, or in other words, we now investigate the geometric properties of parabolas and use them to obtain an equation. By the way, if you like this video, don't forget to like and subscribe to the channel and activate the bell. It's very important for the continuity of this channel. A parabola can be obtained by slicing a cone on a slant as shown below. This curve is known as parabola. Geometric definition of parabola. A parabola is the collection of all points P in the plane that are the same distance d from a particular point fixed f as they are from a particular fixed line d. The point f is called the focus of the parabola, and the line d is its directrix. Look at the curve below. The lowest point is known as the vertex of the parabola. The line passing through the focus and the vertex is called the axis of the parabola, or axis of symmetry of the parabola. We now draw the line known as directrix. The distance from any point on this parabola to the focus must be the same as the distance from this point to the directrix. Notice that the distance being measured to the directrix is always the shortest distance, the perpendicular distance. Because the vertex lies on the parabola, the distance from the vertex to the focus must be the same as the distance from the vertex to the directrix. Therefore, the vertex is midway between the focus and the directrix. This specific distance from the vertex to the focus is labeled by the letter P. Now we are ready to use the definition of a parabola for deriving the following standard form of the equation of a parabola whose directrix is parallel to the x-axis or to the y-axis. We start by placing the parabola's vertex at the origin, because it is the simplest form of the equation of a parabola. This is a vertical parabola because its axis of symmetry is a vertical line. Let's draw the directrix line. The distance P from the origin to the focus will equal the distance from the origin to the directrix. So the directrix has equation y equals minus P. Let P xy be any point on this parabola. The distance from this point to the focus must be the same as the distance from this point to the directrix. And using the distance formula and a little of algebra, we get the equation of a parabola. Pay attention. This is the equation of a parabola in standard form with vertex at the origin. For parabolas with vertex not at the origin, we can shift their graphs. The following table summarizes the translations. When a parabola is translated horizontally by h units and vertically by k units, the vertex of the parabola moves from the origin to the point hk. Such a translation does not change the distance between focus and vertex, or the direction the parabola opens. This is the general standard form of the equation of a parabola. We can use a similar process to find the standard form equation for a horizontal parabola. I will not do that so the video doesn't get too long. The general standard form of an equation of a parabola depends on whether the axis of symmetry is horizontal or vertical. The table below gives the standard equation, vertex, directrix, focus, and graph for each. Pay attention.
Let's see how it works. Let's begin by drawing the Cartesian plane, then locate the vertex and focus. It makes the work easier. The line passing through the focus and the vertex is the axis of the symmetry of the parabola. So we can draw this line as well. We can see that we are dealing with a vertical parabola. The distance from the vertex to the focus will equal the distance from the vertex to the directrix. So the directrix has equation y equals -1. We also can obtain the distance from the vertex to the focus by comparing the coordinates of those points, and with a little help from algebra. To write the equation of the parabola, we take the equation in general form. We replace k with 1, p with 2, and h with 2. In my view, the easiest way to sketch the graph is to remember that the axis of symmetry divides the parabola into two equal halves. If you make x equals 0, then y equals 1.5, and we can see by symmetry that y is 1.5 when x equals 0 or x equals 4. Let's see another example. In the previous question, we had the focus and the vertex and were asked to make the equation and the parabola and its graph. In this question, we have the equation and we are asked for the focus, the vertex, and the graph. So we have to rewrite the equation in standard form. To do this, we isolate the y terms to one side of the equation. We now multiply sides by -1 because it's clearer how to complete the square. Add 4 to both sides to complete the square. We can see that we are dealing with a horizontal parabola. We can obtain the vertex and focus by comparing the equation in general form and this equation. We can obtain the value of p as well. We locate the vertex and focus in the Cartesian plane. We can draw the axis of symmetry in the directrix line. We get the x-intercept by substituting 0 for y and solving for x. And by symmetry, x is -3 when y equals 0 or y equals -4. Finally, we draw the parabola.
Let's see another example. Looking at the graph, we can see that the vertex has coordinates x equals 3 and y equals -1. The axis of symmetry is the line y equals -1. Substituting these values into the equation for a horizontal parabola gives the equation. The point 4, 1 is on the parabola. So we replace x with 4 and y with 1 into this equation to find the value of p. We now can locate the focus. The distance from the vertex to the focus is equal to the distance from the vertex to the directrix. So the Directrix has equation x equals 2. At last, we write the equation of this parabola. Let's see another question. Let's begin by locating the focus and the directrix in the Cartesian plane. We can see that we are dealing with a vertical parabola. The vertex is midway between the focus and directrix, so we can locate the vertex. The vertex is at x equals 2, y equals 2. Let's sketch the parabola. To find the equation of this parabola, we will approach the question from the definition of a parabola. Let x and y be any point on this parabola. The distance from this point to the focus must be the same as the distance from this point to the directrix. We can use the distance formula to find an equation of this parabola. Square each side. Isolate the y terms. Finally, we obtain the equation of this parabola.